What's up, folks? Welcome to Math Walkthroughs with Mr. Weeb. Today we're looking at representing linear patterns concretely, and these are our Lesson 1 Your Turn questions. Let's see what the first question is. It says, what number pattern does the picture pattern above seem to represent? Okay, well, I'm going to put my terms here. Term number 1, term 2, term 3, and term 4 here. And then over here, I'll put my term values. So here we've got 7 bricks, then we've got 2 more, and 2 more, and 2 more. So the number pattern that the picture represents is 7, 9, 11, 13, dot, dot, dot. That's all we need to write right there. Then what we're going to do is we're going to look at predicting what the 20th term is likely to be. In order to do that, I'm going to start with 7 and add 2. And I'm going to do that until I get to the 20th one. Okay, now all I need to do is calculate that. And I could do that on the calculator, but I'm likely to make a mistake. I'm likely to press plus 2 too many times or not enough times. And I think the easier way to do it is this. I'm going to look at all of these, and I'm going to say, how many 2's are there? Well, we added 2 19 times. So that's 19 groups of 2 that we have here. But we also have the 7 that we shouldn't forget to add on. This will get us our answer. So 19 times 2, I should be able to do this in my head because 19 is very close to 20. So I go 2 groups of 20, which is 40, but I only have 19 groups of 2. I have one less group of 2. So that's 38 plus 7. And 38 plus 7, I borrow 2 from the 7, which gives me a 5 and a 40. So that will give me 45 as the answer. Next, in order to describe this pattern with a pattern rule, I would say something like this. Start with 7 and increase by 2 each time. Next it says, describe an everyday situation where that pattern might arise. I might say something like, a growing dolphin might need 7 fish on day 1 and 2 more every day after that. Now maybe that's not an everyday situation in Manitoba, but it might be somewhere in the world. Next we have another situation where we need to predict how many counters will be in the 20th term in this pattern, and we have to explain our prediction. So I'm going to label these terms, this term 1, term 2, term 3, and I'm going to put this into a table of values, okay? So here's our term number on this side, and this is our term value on this side. In our first term, second term, third term, dot, 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 and in our 20th term. So our first term has a value of 6. There are 6 little counters there. Second term, we added 6 more. Third term, added 6 more, right? Every time we go from one to the next, we're adding 6. And adding 6. So I'm noticing that that every time we look here at the term number and here, all I'm doing is multiplying this term number by 6 to find this, right? 2 times 6 is 12. 3 times 6 is 18. So I should be able to take 20 times 6 and get here. Well, 20 times 6 is just like 2 times 6 with a 0 on the end, so it should be 120. So I might explain it like this. Each term value is just the term number multiplied by 6. 20 times 6 is 120, so the 20th term will have 120 counters. Next we're asked, how many counters would it take to show the first 10 terms in the pattern? To do this, all we need to do is list the first 10 multiples of 6 and then add them all up. What's interesting is that if you take the middle 2 numbers and add them together, you'll get 66. And if you take then the next 2 numbers and add them together, you'll get 66 as well. And if you take the next 2 numbers, if you add 18 and 48, you'll get 66. And if you add 12 and 54, you'll get 66. And finally, if you add 6 and 60, you'll also get 66. So if you take this all these colors, 1, 2, 3, 4, 5, we've got 5 groups of 66 in all. And when you multiply 5 times 66, you'll also get 330. It's interesting because, you know, if you look at it, this number and this number is 66, and then 42 is 6 more than 36, and 24 is 6 less than 30. So it would make sense that it would also equal 66. That's just another trick that you can use to help you find the total. Next we have, which pattern has 132 as the 20th term? Now if we remember back to question 1, way back here, when we were asked to predict the 20th term, remember all we needed to do was add our beginning number, in this case it was 7, to 19 groups of 2, because there were 19 steps, and each time they were adding on 2. So we can use that same trick here. So we start at 92. I'm going to highlight all of these in green. That's what we're going to do there. And let's do these in blue. Okay, so if we start with 92, and then we add groups of 2, 19 groups of 2. 19 times 2. Again, 19 times 2, we just know that is 38. And if we're adding 38 plus 92, well, we can join that 8 to the 92, and that makes 130. Okay, so not quite, real close, but not quite there. Let's try the next one. That one doesn't work out. If we start at 56, we can write 56 plus, now we've got 19 groups of 4. 19 groups of 4. Well, 19 groups of 4 is going to be close to 20 groups of 4, right? So 20 groups of 4 would be 80, but one less group of 4, so 76. Let's do 76 and 56. We can add those two together using the old algorithm. So it's going to be 12 here, 12 and 13, and look at that. It's 132. So this one is correct. Finally, we have how much greater is the sum of terms 11 to 20 than the sum of terms 1 to 10 of the pattern 40, 50, 60, 70. In order to do this one, I might want to do some tables of values, looking like this. And now that we have our tables of value, let's go back and look at the question to see what it is actually that it's asking us. It says how much greater is the sum of the terms 11 to 20, that's if we add all of this column, than the sum of the terms 1 to 10. So if we add all of these up. So how much bigger is this whole number than this whole number? All right, so that means we've got to actually add these up. And we can use that same trick that we used last time where we added up these two numbers and got 170. Well, this time we get 170. And we can add the next two numbers, which also add up to 170. And we can add 110 to 60, and that will also give us 170. We can add 120 and 50, that will give us 170. And finally, 40 and 130 will also give us 170. So in essence, we've got 170 times 5. We've got 5 groups of them. So 5 times 7 is 35, that's 350, plus another 500. That's going to be 850. Next, let's do the same for, well, actually we don't have to do the same for the next ones because when I compare at the first term and the 11th term is just a 100 bigger than the first. And this is 100 bigger than the second. This is 100 bigger than the third. Let's check down at the 20th. The 20th is 100 bigger than the 10th term number. So all we would need to do is say, take 100 more than all of these. So 100 times 10 is 1,000, right? So 100 times 10 is going to be 1,000. And so if you added all of these up, it would be 1,000 plus 850. So 1,000 plus 850 is 1,850. And that means we can then do a subtraction question. 1,850 take away 850. Take away 850 is going to be 1,000. And so now we would put this into an actual English sentence, and it would look something like this. The sum of the terms from 11 to 20 is 1,000 greater than the sum of the terms from 1 to 10. That's it for today. Thanks for watching.